Let's look at the rules of exponents along with a few examples on how to apply them. The first rule we see here is that if you divide with the same base, you subtract the exponents. So for example, if I had x to the 7th over x to the 3rd, that'd be the same as x to the 7 minus 3, which is x to the 4th. You know, if I'm going to multiply, I add the exponents. So if I had x to the 5th times x to the 6th, that's x to the 5 plus 6 equals x to the 11th. If I have the same exponent, I can combine them in one. So if I have x cubed times y cubed, I can write that as x times y and then cube it. I can change the order that I would do the problem. Conversely, I can, if I have the same exponent, I can sort of distribute as long as I only have multiplication and division. So x over y to the 11th power will be the same as x to the 11th over y to the 11th. Negative exponents is a big concept. If I have x to the negative 5th, that's the same as 1 over x to the 5th. And if I had 1 over x to the negative 5th, a different problem, that would become x to the positive 5th. Raising a power to a power, if I have x to the 5th raised to the 9th, well, that's the same as x to the 5 times 9, there's a multiplication there, or x to the 45th power. Now, if both have the same square root, I can combine them into one. That's very closely related to some of the other rules, because that square root is a 1/2 power. So if I had, say, the square root of 3 times the square root of 12, well, that's the same as the square root of 3 times 12, or the square root of 36, which is just 6. The same thing is true for division, as you can see. And the big one I'm going to jump ahead to now is rewriting rational exponents as a radical. And that one looks like, for example, x to the 2/3, that would equal the cube root of x squared, or I could write it as the cube root of x squared. And so that looks, if you look here, the denominator of the rational exponent is the root, whereas the numerator is the exponent. So in this example, something that messes a lot of people up is the mixture of numbers with variables. So the first thing I might do is write that as the square root of 16 times the square root of xy to the 4th. And then we can just clearly see that the square root of 16 is 4, and not have to worry about that part. Now, the xy to the 4th, well, you could do it one way or another. What I might try doing is rewriting that as a fractional exponent. The square root is 1/2 power. And now I can make that x to the 1/2, because 1 times 1/2 is 1/2, and y squared, because, again, 4 times 1/2 is 2. So when I write this again, at 4y squared, well, I'm not going to, I was given a radical form, so I'm going to put the 1/2 back into the square root, and there's my answer. For this problem, the first thing you'll notice is I have two different roots here, a square root and a cube root, so I can't just deal with them directly. So I'm going to need to convert them to rational exponents. So I'm going to write them as x to the 1/2 times x to the 2/3. Now, the other rule was said that when I'm multiplying with the same base, I just add the exponents. So that's x to the 1/2 plus 2/3, which is x to the 3/6 plus 4/6, or x to the 7/6 power. Now I'll write this back as in the radical form, which will give me the 6th root of x to the 7th. Well, this problem might look a little crazy. It's just a matter of rewriting with rational exponents. So the square root of the 4th root of x cubed is x cubed to the 1/4, and all of that is taking the square root or raised to the 1/2. And simply just multiply all the exponents. So I have x cubed to the 1/8, which is x to the 3/8, which then I can rewrite again with the radical as the 8th root of x cubed The key to this problem is approaching in steps rather than trying to do it all at once. So in that first step, we're going to have x to the 6th, y to the 9th, because 2 times 3 is 6 and 3 times 3 is 9, times x squared y. Now just kind of grouping them together, I have x to the 6th, x squared, y to the 9th, y, and that's a step you can skip if you're getting a little more comfortable, and then I get x to the 8th, y to the 10th power. And this problem is almost trying to trick you. So the first way to do is just pay attention to that numerator first, and make that 4 to the 3rd, x to the 3rd. That's going to be over 4x to the 3rd. Well, I could multiply 4 times 4 times 4 in the numerator. Yeah, I'm not even going to bother with that yet, because I'll cross out the x cubes, and then I have 4 to the 3rd over 4, which is 4 to the 1st, and to save me multiplying it out again, that gives me 4 squared, and that one I can definitely do in my head and get 16. This problem looks a lot more intimidating than it actually is. So the first thing I'm going to do is deal with this denominator. It's got extra exponents there. So I'm just going to keep the numerator as it is, x cubed y to the 5th, and in the denominator I'm going to have x squared y to the 4th, multiplying the exponents. All of that is now squared. Well, what I can do next, I have two choices. I'm going to choose to deal with everything inside the parentheses. So x to the 1st, y to the 1st, and now that is all squared, which just gives me x squared, y squared.